Agriculture is key to the world's prosperity. Agriculture, or farming, includes cultivating plants and crops and rearing animals to provide food, wool, and other products. Agriculture plays an integral role in social systems and culture, business and industry, economics and politics, and local and international food security. The global importance of agriculture is highlighted in many international documents, such as the Annual Statistical Yearbook and the Report on the State of Food and Agriculture, both presented by the Food and Agriculture Organization, or FAO, of the United Nations. Accurate estimates and forecasts of agricultural activity are a vital component of every country's official statistics. However, it can often be difficult to obtain these estimates using traditional ground-based methods. This may be due to the complexity or geographic dispersion of the statistical units to be surveyed, as well as limitations in road connectivity, technology, or budget. Ground-based data collection can also be affected by broader adverse climate or political events. In these cases, Earth observation, or remote sensing, can be used to improve the spatial estimation and prediction of agricultural activity. Indeed, even if ground observations are available, Earth observation data can improve official estimates. The last decade has seen improved satellite technology, increased access to freely available Earth observation data, and better analytic tools. It's now possible for all national statistics offices to use Earth observation data to develop cost-effective estimation, monitoring, and forecasting programs that can complement their official agricultural statistics and report on a wide range of SDGs. For statistical officers with an institutional mission to characterize statistical phenomena, Earth observation data can be used to improve national statistical estimates and compare with international estimates. They can also be used to contrast the information collected in the field, which can lead to improvements in the supervision of the data collection or adjustments to non-sampling errors, for example. For statistical officers with a broader mission, Earth observation data can be used to produce forecasts or obtain risk estimates, such as the geographic approximation of areas at risk of disasters. A major use of Earth observation in agriculture is for mapping and monitoring crops. This includes remote identification of the type of crop and estimation of the crop area and crop status, as well as forecasting crop yield and assessing food security. Many tools are now available for accessing, processing, analysing and interpreting Earth observation data for agriculture. Some of these tools are free, and some have already been embedded in national statistics offices around the world. The UN FAO provides global and country-specific Earth observation data and indicators. A growing number of countries have access to open-source data cubes, which provide geospatial data management and analysis platforms. Google Earth Engine also provides a number of agricultural datasets and basic analytics. An example of an open data and analysis product specifically focused on agriculture is the European Space Agency Centu-Agri platform. Earth observation is a cost-effective technology that can provide data at a global scale. It has huge potential to improve official statistics for every national statistics office in the world. Although the focus here is on agriculture, Earth observation data can also be used to complement many other traditional sources of socioeconomic and environmental data. In particular, it can be used to monitor many other SDGs by providing estimates of population distribution, cities and infrastructure, the condition of the atmosphere, oceans and climate, natural disasters and natural resources, land use and biodiversity, and human conditions such as poverty. These contribute directly to SDGs for zero hunger, clean water and sanitation, decent work and economic growth, sustainable cities and communities, climate action, life below water, life on land, and partnership for goals. While the methods and tools for using Earth observation data are now well developed, there are still some challenges. The data and information ecosystem is dynamic, and there are still technical challenges in accessing and exploiting the data. There are also methodological and statistical challenges. Research is continuing to address these challenges, so the tools will improve over time. These considerations and the ongoing research are extremely critical, given what's at stake in the production of official statistics. Another key factor that needs to be considered is training personnel to understand and utilise Earth observation data. This applies to all members of the organisation, including managers, analysts and communicators. The work must also be embedded in the organisation's broader strategic activities and decision-making. The training program developed by the United Nations aims to provide personalised support for upskilling based on freely available online courses. The United Nations has created a big data training catalogue on its global platform. This provides links to training courses and other relevant materials to help to develop skills for using Earth observation data and other big data sources in the production of official statistics. Users can identify resources that correspond to their current knowledge and planned goals and create a personalised learning path. This system was first developed by researchers at the Queensland University of Technology in Australia for the UN Task Team on Earth Observation and Agriculture and has now been rolled out to all of the UN task teams. More broadly, users can access a big data competency framework that outlines required skills and identifies skill gaps in the use of big data. By improving skill sets, changing mindsets, and expanding tool sets, all national statistics officers should be well placed to take advantage of Earth observation data for agriculture for the benefit of their countries and the world.